Liquid is poured into a container at a constant rate of 30 cm³ per second. So here what we have some sort of a container, and if we have liquid poured into it at a rate of dV by dt, suppose that rate is A, and at the same time liquid is pouring out, that means negative rate. So dV by dt is B, at which it is pouring out. Then if they say what is the overall rate of water in the bucket, so dV by dt, that would be amount pouring in minus amount pouring out. So this is general idea of finding out about the rates of that is happening simultaneously. So if you take a look, think about this bucket of water, and what you have, the amount of water in the bucket can either increase or decrease. Suppose it depends on, as the water is poured into the bucket, how it is working, and as the water is pouring out of the bucket, at what speed is it pouring out. Based on that, we can make up our mind whether the amount of water in the bucket, whether it's increasing or decreasing. Either way, the rate would be found by subtracting it from the amount pouring in, amount pouring out. So question number A, they mentioned that the amount of water pouring in is 30. So dV by dt is 30. So this is pouring in, and the amount pouring out is 2 by 15 of V. So this is the pouring out negative rate. This is 2 by 15 of V. So if you want to find the overall rate of the water in the bucket, that should be 30 minus 2 by 15 of V. Now this is done, but we have to express it in this format that they ask in the question. So we can multiply both sides with minus 15. So it turns out to be on the left hand side minus 15 into dV by dt. On the right hand side, minus 15 into 30 is minus 450, and this would be minus minus plus, and this would be 2V. So it is shown, we can write therefore minus 15 dV by dt equals to 2V minus 450. And the next part is solving the differential equation. So question number B is solving the differential equation. We have to integrate by the separable method. So let's do this. So this is going to be question number B. dV equals, so let's bring all the V on one side. So 2V minus 450 equals to 1 by minus 15. We want to bring all the constant on the right hand side. So integration, integration. Now to integrate this, remember we're going to use the reciprocal rule of integration. This comes from the concept of opposite of differentiation. So d by dx of ln ax plus b is going to be 1 by ax plus b. So it's reciprocal of the linear into the chain rule d by dx of ax plus b. That means if you integrate this, it has to be reciprocal of a linear. It won't work for quadratic or trigonometric or anything else, only for reciprocal of linear. This would be ln of ax plus b, and opposite of the chain rule would be d by dx of ax plus b. So there would be a plus c over here. So this is going to be ln of 2v minus 450 divided by d by dv of 2v minus 450 is going to be only 2, because derivative of 450 is 0. And here it would be minus 1 by 15t plus c is the constant. So this is the general solution of the differential equation. But they gave the values v equal to 1000 when t equals to 0. Usually they can give us a story that initially the amount of water is 1000 cm³ or something, but they just did not give a story, just t equal to 0, v equals to 1000. So this is going to be when t equals to 0, v equals to 1000, then ln 2 into 1000 is 2000, 2000 minus 450, it's 1550. So 1550 divided by 2, and this would be 0 plus c. So therefore c equals to half ln 1550. We can write down the expression now. So ln 2v minus 450 by 2, that is half, equals to minus 1 by 15t plus half ln 1550. So we have found the particular equation of the differential equation. So the particular solution of any differential equation is when we know the constant already. So we have to rearrange this and write it in the form of v equals to ft in terms of t. So we have to rearrange this. Now we need to know the rule for natural exponential function. This is e to the power x equals to a. Therefore, x equals to ln a, and the opposite is also true. Ln x equals to b. Therefore, x equals to e to the power b. So this is what we are going to use it. Now this is going to be, we can multiply both sides with 2. So this turns out to be ln 2v minus 450 equals to minus 2 by 15 t plus ln 1550. Therefore, e to the power, this is not e to the power. Therefore, 2v minus 450 equals to e to the power minus 2 by 15t plus ln 1550. We can use the rule of indices to break this down as multiplication. So e to the power minus 2 by 15t into e to the power ln 1550. And you remember, e to the power ln anything is that thing. E to the power ln x is x. So we can just write the value of e to the power ln 1550 as 1550. This will be e to the power minus 2 by 15t. So this is 2v minus 450. We can write 2v equals to 450 plus 1550 e to the power minus 2 by 15t, and now we can divide both sides with 2. So v equals to 450 divided by 2, that's 225, 2 to the 4, 225 plus 1550 divided by 2 is going to be 2 7 the 14, 775 e to the power minus 2 by 15t. There is one more question here. It says find the limiting value of v at t tends to infinity. So when t tends to infinity, you have to remember e to the power t is 0. So it's better whenever you have a question like that, t tends to infinity. So what you do here, right, for e to the power minus 2 by 15 t equal to 0. So write this first. It would be 225 plus 775 into 0. So this would be 225. Since e to the power minus 2 by 15t is cannot be equal to 0, it has to be greater than 0 because of the asymptote. Hence, limiting value is 225.